Okay, here's another one that should be pretty straightforward. I think we're going to start with the reactant. I mean, it should be pretty obvious. 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. We're going to have 8 carbons versus 5 carbons, so we need to add 3. And the other thing that's a big clue is that this is a cis alkene, and there's really what cis alkene tells us is that it's not an elimination, right? Because unless it's an E2 elimination where there's only one beta hydrogen, you don't get cis alkenes. You get trans alkenes because they're more stable. They're lower in energy. So what that means is that's going to be a reduction. It's going to be a reduction from H2 and Linlar or another poison catalyst. So if we start right here, then we know if that's the case, right? So I have to have a reduction. Rotate this just a little bit. All right, let's see here. My drawing skills are bad today. All right, one more time. 1, 2, 3. 1, 2, 3, 4, and then it would have to be here. And that would be a total of 8, I think. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we got our 8. Let me just clean this up just a tad bit. And this would be H2 and Linlar's catalyst. Okay, so let's continue to think back. Now this is, remember, we're adding carbon-carbon bonds. And for most of my classes at this point, the only way we know how to add carbon-carbon bonds is through alkylation with an alkanide ion. And that's going to make sense here because the product is a alkyne. So I know that at this point, I must have added a propyl group, 1, 2, 3 carbons, and it had to have some sort of halogen attached to it. And in order to get to this point, I would have needed to make this into an alkanide ion. And so in order to do that, I needed some sodium amide. And so that would have made this into an alkanide ion. And then I got the rest of the reaction, got it done. Okay, that's it.